might just start by asking, how many of you are really interested in beef cattle or raised beef cattle? Okay, good. I actually brought some data slides. I'm thinking I might gloss over some of those and talk a little bit more about the impact that some of this research could have on the industry, and I'll be glad to get into some of the more details of the research if you'd like afterwards, because I know we want to get to Marshall and there's some other presentations. I thought you might be interested in just kind of an overview of the beef industry in this country. Every dot that you see on that map represents 2,500 beef cows. And a lot of people think of the beef industry being in the western part of the United States, but as you can see, the majority of the beef cows are right in the center, going from south all the way to the north, and that actually it's between the mountain ranges. There's a concentration, of course, in Kentucky, moving up this direction, southern Ohio, that sort of thing. There's also another band through Tennessee, going up into Virginia. And of course, interestingly, there's a pretty large group of cows there in Florida. But I thought you might be interested, and of course, Missouri has always been a major beef state. We flip-flop back and forth between Oklahoma and us in terms of being number 2 in total number of beef cows. Here's just a little bit of information about the beef industry. We're at about 31 million cows right now, and that's on about 600,000 farms. This is actually up a little bit from a couple, 3, 4 years ago, where it got down to maybe 28 million. Interestingly, almost 70% of beef cattle operations are a secondary source of income. And this makes it a challenge to people like Dave Patterson, of course in Extension, other people in Extension, but myself as well, in terms of encouraging people to utilize some of the technology that we know is profitable in the beef industry, because this is oftentimes a secondary source of income, and beef cattle production, not for everybody, but for a large portion of people in this country, is really a byproduct of land ownership. About 50% of producers have an established breeding season. So if I could do anything to help change the beef industry, I would try to increase that number to where you've got more people with a defined breeding season. I'm going to try to convince you that having a defined breeding season can be profitable. Only about a third of beef producers routinely diagnose pregnancy in their herd, even though we know that feed costs take up about 60% of the cost of maintaining a cow for the year. So you'd think you'd want to get some of those cows that aren't going to deliver a calf out of your herd, so you're not continuing to put those feed resources into them. Only about 10% of beef herds utilize AI. So one thing I wanted to talk about is that in beef cattle production, it's not just getting pregnant that's important for a beef cow, it's when she gets pregnant. Getting pregnant early is very important to a beef cow and to profitability. That's why a defined breeding season can be helpful. Let me just show you why. So here's some data that talks about the difference between a heifer that was born the first 20 days of a calving season versus the second or the third 20 days of a calving season. So we're not talking about calves that are 100 days, 120 days apart. We're talking about calves that are maybe 20 to 40 days apart. So those heifers born the first 20 days have a higher weaning weight. Well, that makes sense. We tend to wean at a fixed time. So those heifers born the first 20 days are going to be older and therefore heavier. But this advantage continues in that these heifers have a higher pre-breeding weight, and they have a higher pre-calving weight, higher percent cycling by the start of the breeding season, and that translates into a higher pregnancy rate. So these heifers that are born early tend to make better replacements. Now, what I thought you might be interested in is, what about on the steer side of things? Well, yes, we get the same advantage in the steers that we get in the heifers due to those steers born the first 20 days of a calving season are going to be older, therefore heavier than the steers born the second or third 20 days. But this is what I thought you might find interesting. The carcass quality or the carcass impact of this. So, steers born the first 20 days of a calving season compared to the second or third 20 days, all managed the same. Those steers the first 20 days, they were born then, higher hot carcass weight, increased marbling score, increased average choice or greater, and therefore increased carcass value. So it's amazing that this 20 to 40 day difference in when they're born translates into a higher quality end product. Well, these are some data that just show how you can decrease the length of a breeding season and the impact it can have on profitability. This looks like a lot of information, but it's really pretty simple. What this shows is the average length, or the average day a calf was born. So about the 80th day of the calving season. So this is a 160-day calving season. This was, and you see the second year was like that. Well, the third year, what they did is they implemented what's called a fixed time AI program. What that meant is they synchronized ovulation, not estrus necessarily. They synchronized the time all these cows ovulated to the first day of the breeding season to look, and then they looked at what effect that had on when these calves were born. And notice that average day the calf was born was reduced by 21 days. Average day is now 59. This is $87 increase in calf value. Now you're saying, well, what about the cost of the AI and what it takes to synchronize them? That's about $30 per animal with the labor. So you're making about $50 per calf. This was a herd of 300 cows. That's what it translated into. Make a long story short, that after several years, the average day that these calves are born went from about 80 down to 38.7, increased value per calf by $169, and that was the profitability just from that management technique. Well, how do you go about synchronizing ovulation? This is the ovary of a cow, and this right here, this blister-like structure is a follicle, contains an egg, and you can get these cows now to all ovulate that at the same time. So Dave Patterson, who you know well from the Show Me Select Heifer program, and myself to a certain degree have spent our careers trying to understand how to grow one of these things and how to then get them all to ovulate about the same time. When this ovulates, it forms a little structure like this in the ovary, and this produces the hormone that maintains pregnancy. So we've worked a lot on some of these protocols that look like this, where you give a shot that sets the cows up, you wait 7 days, and that structure I just showed you right here, you have to get rid of that. So you give another shot that gets rid of that, and then that allows the cows to prepare to ovulate. So 3 trips through the chute, we can ovulate them all at the same time, and they're all inseminated at that time. And we can get about 60% of these cows to conceive at that breeding. So we can get about 60% of these cows to conceive the first day of the breeding season to genetically superior bulls. What do we mean by that? We mean these are bulls that have been identified as being superior in economically important traits, calving ease, for example, carcass quality, growth, things like that. So one of the things I've worked on is this follicle here. I've worked on trying to figure out what's an optimum type of follicle to ovulate to maximize pregnancy. What we found was that there are follicles in this range here, that size range that is, that if we can get them to that size, when we ovulate them, we have a pretty good chance of pregnancy. If they're smaller than that, notice the pregnancy rate drops off. Now this is a pregnancy diagnosis we did at day 27 after breeding. This is at day 68, which means that these follicles in this category not only are resulting in a lower proportion pregnant, but those that are pregnant here, we're losing some of their embryos. So we're trying to study the biology of that to figure out how we can shift some of these follicles this way and increase pregnancy rate. I'm going to move through some of this to talk just for a moment about a project that Dave Patterson has been leading in the state. It's called Split Time AI. At this time here, when you go to breed these cows, you have 2 populations. You got cows that are in heat at about the time they're going to ovulate. You got other cows you can get to ovulate, but they don't actually show heat. And the cows that show heat when they ovulate, we have a better pregnancy rate than those cows that don't. So what can we do about that? I know that looks like a lot of information. I just wanted to show you that this is what we normally do at AI. We give a shot to all the cows or heifers, regardless of whether they've shown heat or not, and breed them. What now Dave Patterson's been doing is at this time just breed the cows that are in heat. Those that aren't in heat yet, these heifers, what you do is you give them a shot that starts the ovulation process, breed them the next day. How do you tell if they're in heat? Well, it sounds like a time-consuming process being out there watching them, which is one way to do it. But what there are these little patches you put on the tail head, and when they get mounted, some of that gets, it's kind of like, I'm not one who buys lottery tickets, but if you did and scratched it off, that's about what it's like, actually. It's like scratching off a lottery ticket. In other words, the more this heifer gets mounted, the more that rubs off. And so this would be a cow that's fully in heat. Well, let me just show you quickly some results here. So here's of the animals that are in heat, got about 52% of those not in heat, 34%. So you can see if they're in heat, they both ovulated, but you get a better pregnancy rate. Notice that the ones in heat in this group were the same as the ones in heat in this group. We expected that. What was interesting is, here's the ones that were not in heat where we delayed insemination. We got a much better pregnancy rate than we did over here. So that's something you'll be hearing more about for those of you interested in AI. I wanted to say a word about sex semen. That is, we have the ability now in cattle to accurately sort sperm cells into those that will result in a bull calf versus those that result in a heifer calf. So you probably know the ones that carry the Y chromosome, that's going to make it a male. The ones that carry the X chromosome, a female. So what happens is these sperm go single file through this tube. I won't explain the process unless you're interested later, but you can separate them into those that are going to make heifers right here or bulls. This is being used a lot in the dairy industry at the moment. There's about 1,800 sires, Holstein and Jersey, that this procedure is being performed on, and it makes sense. The dairy producers really want heifer calves. Holstein bull calf is worth very little money, and so they've adopted this or are adopting it increasingly more and more. There's about 40 semen processing facilities in 15 different countries, and in the US, about 14% of dairy heifers are inseminated with sexed semen, 3.5% of dairy cows. It doesn't seem like a lot, but they can generate a lot of the heifers they need from that. What I think you're going to be hearing about in 10 years, you're going to hear more of this being done in beef cattle. Why? You could identify your best cows, your most maternal cows, and then what you'll use is you'll take semen from the most maternal bulls that have been shown to be exceptional for maternal traits, and you'll use this semen right here, this X-bearing sperm semen, to inseminate those highly maternal cows of yours, and that's how you're going to get your heifers. And all the rest of your cows, you're going to use the Y-bearing sperm, get steers because they bring you more money. We're not there yet, but we're on our way. I have all this little data. I won't go through all that with you, but I'll be glad to talk to you about it later. I just wanted you to know that's something that's coming on. Now, did you ever wonder when you breed a cow, what's the probability she'll get pregnant? Depends on when. Interestingly, fertilization rate is very high. So in other words, by 3 days after you've inseminated a cow, either artificially or natural service with a bull, 90 to 95% of those cows or heifers are pregnant. But by about a month later, 25% of those embryos have been lost. You're now down to 70%. Then, when you get out to about 2 months later, or 42 days later, you lose another 8%. So now you end up with about a 60% pregnancy rate. It doesn't matter if it's AI or natural service, it's the same thing. So this is what we call early embryonic loss, and this is a failure of that very early calf to send the mother a signal saying, hey, I'm here, don't come back in heat. For some reason, 25% of those embryos can't do that. So this is something that's being studied here at the university very extensively. The actual signal that the embryo sends out, this IFNT, it's interferon tau, that signal was actually discovered at the University of Missouri by a guy named Mike Roberts. But this whole process from fertilization up through the sending of the signal is being investigated, and what people are trying to do is figure out how to get more of these embryos to be able to send the signal. So this is kind of a basic science approach initially, but that will be able to be translated into production, hopefully in the near future. One other thing that's being looked at is we know that some sires have a very high pregnancy rate when bred to cows. Other bulls have a low pregnancy rate. We're studying about why that's the case. We know two things so far. We know that those high fertility sires have an exceptional ability to fertilize an egg and create an embryo. The low fertility sires are not able to fertilize the egg as well. That's one thing. But we also know that those low fertility sires, they're getting some pregnancies started, so they have some embryos developing. And beyond this point, shortly after this point, those embryos are not surviving. So we're trying to understand why. As I mentioned to you, with beef cattle, it's not just getting pregnant, it's when she gets pregnant that's important. So trying to push this pregnancy rate up, if we could just push it up to 80%, well, let's go out here. If we could just push that up to 70, 75%, that would allow us to shorten our breeding seasons. It would allow us to get more cows pregnant early. Those calves would be born earlier, and they would weigh more. So that's something we're really trying to do. So let me move on here. Let's just talk about, just go back to history for a second and talk about how this relates to a new emerging concept in beef cattle reproduction, or in beef cattle. I'm moving on more to nutrition now. During World War II, it was 1944 to 1945, Nazi Germany isolated a portion of Holland. And what they did is they cut off food going into Holland. It's reported that people were trying to survive off 200-300 calories a day. There were women walking 2 miles to be able to get the equivalent of a tulip bulb to eat. So this was for a number of months during that winter until the Allies broke through and got rid of the blockade. What does this have to do with anything we would talk about today? Well, a number of years later, there's a guy named Barker who thought to himself, I wonder what happened to the children born to women who were starved during that period of time? Was there any long-term health consequences? So this is how this idea of prenatal programming got started. So what he did, he went back and looked at the health records of children, babies born to women who were starved during early gestation, middle of gestation, or late gestation. And there was another part of Holland that wasn't under the blockade. So he had women giving birth who had not been starved. And he could compare the records of those two different groups of children born during that time and found that the children born to the women who were starved tended to, when they were my age, tended to have cardiovascular problems, had problems with diabetes, problems with obesity, a number of different health problems. So this started this whole idea of how nutritional availability to a fetus in utero can actually program the physiology of that baby, in this case, for its lifetime. Well, how does this relate to cattle? Well, first of all, maternal environment, nutrition in particular, can definitely program heifers and steer progeny in regards to how they grow. I'm going to show you something about that. And we know that gestational nutrition can affect placental efficiency. That's the tissue that transports nutrients to the offspring. Fetal organ weight, but also weaning weight and carcass quality. So let me just show you that. Here's some data where two groups of cows, and during mid-gestation, this group received no supplement, just kind of a low-quality hay. This received just 1 pound of protein per head per day. Now, these are the heifer calves. The heifer calves born to those cows that received the supplementation had a higher weaning weight, But what's interesting here, now remember, once these calves were born, they were all managed together. The only difference was that the mothers of these heifers got this supplement during gestation. These did not. These heifers reached puberty earlier, higher pregnancy rate. What about on the steer side? Can't see where I'm at here. Oops. So on the steer side, the steers born to the mothers who were supplemented, higher weaning weight. Look at this, higher percent choice, affected carcass quality, and marbling score. So Allison Meyer, the university, is looking at how maternal nutrition programs the offspring. And I would say for those of you that develop heifers, we think of developing heifers or managing heifers starting at weaning. You're going to start managing your heifers while they're still in utero within about the next 10 years. We'll know some things you can do to try to help set that heifer up for success. So just a few things on nutrition, just to kind of wind up here. There's a lot of research going on at the university to try to better understand metabolic efficiency. Tolerance to fescue. Fescue is a double-edged sword. There's some great things about it, but the downside is there's a fungus associated with it that produces ergovaline, and this can cause heat stress and can reduce pregnancy rates. So there's a lot of work trying to figure out which animals are tolerant, which ones are susceptible. I'm going to say a word about residual feed intake. I'll tell you what that is. And we're going to talk a little bit about how to diagnose for respiratory disease. So they did this experiment. Well, first of all, the background. What's the problem? The problem is this. Feedlots in Kansas, Nebraska are a little bit, well, what's the word? They're a little bit resistant to buy cattle out of the fescue belt because they feel like the cattle don't perform quite so well. So we're kind of interested in what can we do to set up these calves for success? And is there really even any effect of fescue once a calf gets into the feedlot? Well, they set up this little project. It's a 54-day feeding trial. Half the animals got fescue seed that was infected with this endophyte that makes the ergovaline. The others did not get it. And what they found was, importantly, they conducted this trial during the winter because they didn't want heat stress to be a complicating factor. And these calves on these two different diets actually performed fairly similarly during the winter while they're on this feed trial. Then they went into the feedlot. And what happened was, when they went into the feedlot and they were now on a common diet, those steer calves that had been on the infected fescue did not perform as well. They didn't grow quite so well. But their carcass weight was about 35 to 40 pounds less than those steer calves that were never exposed to fescue. So now they're trying to do two things. They're trying to figure out, is there some way of treating these calves dietarily that can prevent fescue or the ergovaline from being a problem? And then second of all, how can you screen calves to know who would be really susceptible and who wouldn't? So they've now developed a genomic test at the University of Missouri called T-SNP. And it's a test that you can go in and look for a genetic marker that will indicate these calves are either resistant to fescue or maybe more susceptible. And there's a company called Botanica that's been developed by a couple of faculty members at University of Missouri that can actually analyze your data. You can put blood on a card, or you can put a piece of hair, some hair on a card, and you can get this analysis. You can ask me, how much does it cost? I can't remember, sorry. I forgot to look that up. Just going to end up with a couple things. You're going to hear the word residual feed intake. So feed efficiency is of utmost importance to the beef industry. Like I said, a cow-calf producer, about 67% of the cost of maintaining a cow is feed. In the feedlot, they'll tell you their profitability is very much linked to feed efficiency. So what is residual feed intake? It goes by the initials RFI. So what you can do for an animal, there are equations that will predict how much feed this animal should consume. Let's say it's 20 pounds. Then what you do is you measure, and I'll show you the equipment you do this in, you can measure how much they actually do take in. If they take in, let's say, 15 pounds, they're able to maintain the same performance, but on 15 pounds of feed, that makes it negative. So that'd be a negative RFI steer. If, on the other hand, instead of 20 pounds, it's something like 25, 28 pounds, that's positive. So a negative RFI, that's calculated by the difference between the actual feed intake and the expected. The negative is going to be more efficient. Why is that important? The other thing, it is heritable also, I should tell you. And what they're doing is they're measuring this in bulls, so that when you go to select a sire, let's say you buy a bull, you may be able to find out whether he's ever had his RFI examined, or maybe his sire did. A lot of sires that are ending up in bull studs have undergone this type of analysis. But about the negative RFI results in a 10 to 20% decrease in feed intake, about a 25-30% reduction in methane, and about a 15 to 70% reduction in manure. And it is heritable. So this is the equipment. That's the best picture I could get. I know it's not very clear. What's interesting is these animals come in, they stick their head in to eat, and what it does, it automatically reads their ear tag, and it'll measure exactly how much feed it takes. So it's weighing that bunk there, is measuring how much feed that calf actually took in. And then the next calf comes in, and it keeps these measurements. You can also do the same for water. There are these bunks where they have water in, and it'll measure how much water these calves are consuming each day. Well, this is my last slide. Respiratory disease, major problem in the feedlot. How can this equipment be helpful in that regard? Well, what you can do is on your computer, it'll plot out for every calf how much feed they're eating every day. And you can sort of plot a line based on their feed consumption. When you see that feed starting to go down, that's an indication that calf's getting sick. And what they're trying to figure out is, can we actually determine that a calf is starting to get sick before it develops a really high temperature? And they're going to be examining the decrease in feed intake, but also the decrease in water consumption. So what I've tried to do today is just give you a real broad brush picture of some of the things that are being done that might be able to be applied. I'd be happy to hang around and talk to you individually. I know some of you aren't interested in beef cattle, some of you are. So for those of you who are, I'd be glad to talk to you. And for those of you who aren't, you should just know this is a huge beef state. Beef cattle is very important to our economy. And when you're driving on the road and you see those beef cows, there's a lot of sophisticated science being done that's going to be able to be applied to those. So with that, thank you very much.